In this project, we are going to enable GPIO input and output of STM32. The components that you require for this project are STM32 Blue Pill, and the microcontroller used in this board is STM32F103C86. You need a push button, 3 LEDs, and 3 resistors. I am going to use 100 ohms resistors for this project. You could use 220 ohms or other resistors in this range. This is our intention in this project. Now I will explain it to you. I want to press the push button, and whenever it is pressed, I want these LEDs to start an animation for us, a simple animation for us. You see the breadboard here. I have connected my blue pill to the breadboard in this manner. Here is the USB, and here with these pins 3.3 through G and D, blue pill board gets connected to my laptop. It is oriented in a manner that it is along with outer side of my breadboard, so it is connected to my laptop easily. I've connected one pin of the push button to 3.3 volts and the other pin to B11 pin. Why is that? Whenever it is pressed, the button is pressed, 3.3 is connected to B11. In other words, it has reached a high value. So we could tell the microcontroller when it has reached a high value, it does something for us. And whenever it is not connected, it is high Z. It is not connected to anywhere. So we're going to say how we could pull it down. And don't worry if you don't know what is pull up and pull down. We would review these concepts completely. Thanks God, in STM32 we don't need extra circuitry for pull up and pull down. Everything is done inside the microcontroller. I have connected the positive pin of LEDs. As you know, LEDs are actually diodes, so they have polarities. You must be careful about that. Connect the positive pins of LEDs to B12 and 13 and 14 respectively, and connect the negative pin of the LEDs to the ground, and then they could work. And here I've forgotten something. You need to connect the ground of your board to the ground side of the breadboard. I guess you are familiar with breadboards, and these lines are connected to each other horizontally. As you can see, I've pressed it, and these holes are connected horizontally again. So this hole is connected to this and this and etc. But these pins in the middle of the breadboard are connected vertically to each other. So be careful about that. Here is our circuitry. So let's do it in the real world. Well, here are the required components. Our blue pill board STM32 connected to ST-Link. And don't worry if you've forgotten how to connect the board to ST-Link, we would review it. 3 resistors, 3 LEDs, 1 push button, and some jumpers. So let's connect the blue pill to board as mentioned earlier. Do it carefully, not to hurt your board, so you could use it later. And about the push button, these pins are connected to each other, and it is
indicated with a line, and the other two pins are connected to each other and it is indicated with this line. But these pins which are in front of each other, they're disconnected. This is true about these two pins as well, and they are disconnected diagonally as well. They get connected to each other just and just only if I press they get connected to each other just and just only if I press this button. Otherwise, they are disconnected. Well, so I keep the orientation and I connect the push button somewhere like here. Yeah, it would be fine. Then we would connect jumpers here and no disturbance when we want to click the push button from here. So everything is all right. About the push buttons, and the shorter leg is the negative pin of my LED, and the longer leg is the positive pin of my LED. Of course, you could check it from the inner side of the LED, and the thinner one relates to the long leg, and the thicker side is related to the shorter leg. The shorter leg is negative, the longer leg is positive. The negative pin must be connected to ground. I keep it away from the microcontroller. I do the same for other LEDs as well. The thinner leg, I connect it far from the LED. The distance is so much, 2 holes is enough. Then I want to connect the negative pins of the LEDs to ground via 100 ohms resistors. I could do it so you could see them better. Again, connect the negative pin of the other LED to ground as well. And for the last one, let's do it. The LED's power is provided from the microcontroller, so they must be connected to the ground of the microcontroller. We have some options here. It is ground, it is ground, and it is ground as well, G and D. So we have 3 options. In my case, I have to resolder this pin. It is not connected completely. So I use one of these 2 grounds, connected to here. All these holes are connected to each other. So all the resistors are connected to the ground of the microcontroller. Whenever I connect it to my PC via this USB, the power of the LED would be provided. Thus, the power of LEDs would be provided as well. And I connect one pin of the push button to 3.3 volts. This way. Yep. And the other leg to pin B11 as mentioned earlier. So B11 is going to be the input because we are giving the data to the microcontroller by pressing the push button. And B12 and B13 and B14 would be our outputs. So connect the positive pins of the LEDs to these pins respectively. B13, and the last one is B14. Yep, the circuit is ready. Let's do the programming stuff.